Uh, I believe I am audible. Welcome, everybody. Welcome to TP on trees from scratch. So, this is a very interesting topic, and I'm very excited to discuss this. So, this has a lot of applications. We can make DFS, BFS trees out of graphs, maybe find bridges, articulation points, maybe travel in a tree, calculate properties alone, maintain arrays. Also, we will also learn about rerouting, where we try to change the route and without physically changing the route and doing DFS or BFS every time, we try to optimize it somehow, as in we do it dynamically. Like if this is the route, then what? If that is the route, then what? We calculate for all the nodes being routes without even making them route fully. We play some tricks, maybe do it while doing the BFS dynamically. So this is a concept of rerouting that I also want to discuss. That will come later. We want to discuss traveling in a tree and maintaining array. That is the crux of this maintaining, basically not array, I would say a data structure. Can be set, multi-set, anything. That is the entire idea of DP on trees. We will learn this concepts through way a lot of examples. So let's get started. So we will start with this problem. This problem is called subordinates. Just give me a moment. Yeah. This is good enough. This is the first problem that we are going to discuss. Let me switch to dark mode. So let's read the problem and try to understand what it is being said. So we are given a structure of a company, and I want to know how many subordinates does it have. For example, let's consider this tree. Any generic tree does not necessarily have to be binary. We want to know how many people are working under me. For example, for this person, the answer will be 0 because nobody is working under this person. This for this person 0, this person 0. For this person it will be 3 because 3 people are working beneath him. Or you can say that subtree size of that node excluding that node. For this the answer will be 0. For this the answer will be 3 plus 1, I believe 4. Or 1, 2, 3, 4. No, it will be 5 because like this 1, 2, 3, 4, and 5. For this the answer will be 0. For this the answer will be 1, and for this the answer will be, I believe, like 5 plus 1, 6, 1 plus 1, 2, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Yeah, so 8 people. Uh, this is the crux. I mean, this is the question, but it is what we are trying to find. Now, we want to, while looking, while getting these kinds of problems, we want to check for some properties that we are maybe recalculating. For example, can I say the number of children a person has is equal to like the number of subordinates a person has is equal to the number of children he has if it is 1 above. If it is leaf node, then it is number of neighbors I have except the parent minus 1 if I am leaf. Like, for example, let's say this person does not have any leaves. So for that, the answer is known to be 0. For this thing, can I say the answer is known to be the number of nodes I have, not necessarily number of nodes. Maybe the I will calculate, add them, and with them I want to add their subordinates as well. So for this one, the answer will be number of neighbors they have, which in this case 3, and their subordinates. So for this, the answer is 0. So it will be uh, like 1 plus 0, 1 plus 0, 1 plus 0. For each neighbor, contribute 1. And if that person has to contribute more subordinates, good. For this 5, we can do it like I know that this person has 3 subordinates. So 3, so 1 plus 3. Because 1 directly and 3 from your subordinates. It will be in 1 plus 0 because this person does not have any subordinates. So it can be shown like answer for I equal to answer for neighbor of I. Like first I want the answer for the neighbor of I plus 1 sum for all neighbors. Uh, like all neighbors belonging to neighbor set of I maybe. So for every neighbor set of I want the it being added basically. That's the idea. So for every neighbor, I'm adding 1 because of that neighbor. And we are also adding the neighbors it further has. So this is the idea. Now let's get back to the problem. So they have given us a tree. So like 5, then 1, 1, 2, 3. They have given us the boss directly. Like uh, a tree has n nodes, n minus 1 edges. So if I have 5 nodes, I am expecting n minus 1 edges, that is 4 edges. Now it is telling me that uh, the first node, 1 is the boss of 1 maybe. 1 is the boss of 2. Or I can say that, like, let me give you an example. Let me copy this. I will help you out how to interpret this maybe. So let's say I want to interpret this. Like I know that I have 5 nodes, right? So this is the significance for 2, 3, 4, and 5. First node, we don't have a parent because that's the root. So if we check the output, we see it's 4, 1, 1, 0, 0. And yes, so for 1, the answer is 4. For 2, the answer is 1. 3, the answer is 1. So for everybody, I want to know the number of subordinates I have in order. N is up to 10 to the power 5, so we can do DFS only once. We cannot calculate subtree for everybody, and we will not do anyways. Let's go back to the coding screen. See if I can parse this. Just give me a moment. I'm trying to parse this problem. Yeah, we have the problem ready. Yeah, I think the screen is way too big. Yeah, this should work. So let's go with the basic template. Mm, let me just fix this. Done fixing. So we have a tree. So let's make a tree. Let's say tree. Now, I believe for n minus 1, so for now we want to have a link between the parent and the child, and also so we will make a bidirectional graph basically. Let's go from I to I think n will work. T of I dot pushback x and T of x. So we have made a bidirectional graph. Now after making the bidirectional graph, we will maintain an array. I think we have defined our array to be answer. So let's define the array. So now we will define our function. We'll give a node. I think LL would be good. It does not matter. We can keep int anyways. Since it is recursive, so we will also keep it reference. So we will say if a set of this or I could say that if for maybe LL neighbor through my node T of node, you can just say that if let's say int answer equal to 0. I mean for the current case, we can just say that if this neighbor is parent, then we can continue. Otherwise, I think we can believe we can do something that answer equal to answer of neighbor plus I think 1 for every. For the last nodes, there will not be any neighbor other than the parent, so answer will remain 0. So I can just return answer. Mm, or I could, and before returning answer, I would say that answer, let's say this, let's call it race. Um, Otherwise, continue. Otherwise, I will have to run the DFS. Otherwise, the answer will not be prepared. So self. I think my node is the neighbor, and the parent will be node. After all this is done, I will say that if all the answers are created, now I can maybe for every neighbor, I can do that I don't need actually require the zero, but anyways, result is equal to answer of neighbor, because that has been prepared, plus one, and return this answer of node equal to answer, I think. No, not answer, I should say result. I think this should be good because say I run through every DFS, I make every DFS calls, all the answers are prepared. Now I say that, okay, get all the answers plus one every time, and maybe return that. So we just do it. Let's try to print. I think I want my self-reference one, and the parent can be minus one. And I think I want the parent for everybody, so I want the entire loop being printed. I think one will be good. So I can just say that that is good. So see out answer of I. Maybe some space would be good. Let's try to run this. Okay. Okay, I think the answer should have size n plus one. Accommodate all, otherwise. Okay, it is 0. Hmm. thinking maybe we have not defined base case. If we want. Yes. Can I have a printout of this? For one, it's not 0 for it's nothing. For one, it's connected to 2 and 3. For 2, it's connected to 1 and 4. Yeah. For 3, it's connected to 1 and 5. Yeah. 4 is connected to 2 and 5 is connected to 3. As expected. Okay, I have not called DFS for anybody. Maybe you should call it for DFS 1 and -1. I have not called through DFS function. Mm, you don't need to return anything. Just deduce it to void. Yeah, it has passed. I don't think I require these error messages. I should have called the DFS function. Other than that, everything was correct. So this is the code. This is the solution to our problem. Let's try to submit this. Okay, let's so it is getting accepted. As you can see, we have submitted the same code that we have written. Okay, let's try to solve the next problem, that is tree matching. So we are given a tree consisting of n nodes. A matching is a set of edges where each node is an endpoint of at most one edge. Matching set of edges is where. Okay, let's try to make the tree. Let's see how it looks like. So we have a tree of 5 nodes. Okay, now we have to check how many matchings do I have. Okay, so a matching set of edges is where each node is an endpoint of at most one edge. So it's telling me that 1, 2 is a matching, like 1, 2, 3, 4 are matching. So let's consider this edge 1, 2, and 3, 4. Now, why am I considering them matching? Okay, I get an idea. So it's trying to tell me that let's consider that these two in a matching. Question is, can I do it? If I consider these two in a matching, then it's not possible because each node in the matching must be connected to only one edge. Like this node is connected to this edge as well, this edge as well. This is not allowed. We are only allowed to have those edges such that uh, all the nodes that are connected to those edges have nothing in common. Like, let's say this is a network. So if I consider this edge, that means this node is gone, this node is gone. Or we can say that I cannot select this edge as well, this edge as well, this edge as well. Now, if I select this edge, that means I cannot select this edge as well, this edge as well, and this edge as well. So basically, if we consider edges as nodes, let's consider this tree. This is given in the question, and let's consider the edges as nodes and the nodes as edges. Let's try like 1, 2. Let's consider this as a E. Let's say this is another E, 3. Let's say this is another E, 4. This is another E, and a 5. Now, if we consider this E, then every node connected to this E is gone, gone, gone. That means I cannot select this E. Now, how can we solve this? We have to do it by DFS. Maybe maintain some arrays. I'm thinking like, can I use disjoint set union? Maybe I'm overcomplicating this. Just, if I post my yeah, found it. Okay. Let's try to understand. Let's say I am doing a DFS. Maybe I can use some type of recursion and ask. So it's like, okay, uh, I am on the edge 1, 3. Since I am on the edge 1, 3, I will tell this 3, hey, I came with a -1. That means I have selected this. So tell me how much you can match by not considering your neighbors. Like if I give a -1 to you, you will send +1 to everybody and get their answers and tell me. Of course, in a tree from a node, if multiple nodes are connected, then I can only give -1 or select one of those edges. Like if I'm standing on one and there are multiple edges, I can only select one of them. And whichever I select, I have to tell the rest of the people, hey, what is your answer? Considering that I chose you. That means I chose the edge connecting between me and you. So you cannot choose any edge between you and your subordinates, but your subordinates may choose. I'm thinking, is it always optimal for me to maybe level this out? Because uh, I'm thinking, is my answer dependent on root? So I'm thinking like, uh, does my answer change if I change the root? Say I change the root, then the answer is this. This is gone, and this. So the answer is independent of what root I choose. If that is the case, maybe I can say that if there are three levels, the answer is always 1 minus the level. No, there can be more matchings. Like, what if it is like this? If I select this, I select this. So it's like 1, 2, 3, 4. How many levels? 1, 2, 3, 4, 5. What if there is one more? So if all of these are on one level, all of these are on one level. So no. So from a node, if I send one to one person, I have to send -1 to all the other persons, and I have to maybe maximize. But there will be a lot of optimization. Like as in, there will be a lot of recalculations. Like a lot of times, a person will call me with a -1, and a lot of people will call me with a +1. With in many cases. Okay, let's see how much we can put this. To VS Code. So first we have a tree. I think we can use some of the codes of this. That n plus 1 as it is, and we'll read an answer something, but not thought of it now, and maybe 1 to n minus 1 t of, I think we'll have two indices x y. So this creates our tree. Now for every node I want the answer if it is 1 or minus 1. Like it's a 2D array. Like it's a n by 2 array. Let's say answer, just simple. N by 2 array. For the leaf nodes, what will be the answer? We'll think about it. Let's make that simple DFS call at least. We have a basic DFS system. Now, a lot of things we have to consider that maybe int parity. Uh, to call to everybody. Parity will be 0 because we don't care about parity in the first case. Now let's say I will consider two types of parity. If I came with a 0, of course I'm allowed to pick an edge on this level to my neighbors. If I came with a 1, I'm also allowed. But if I came with a minus 1, I'm not allowed. So neighbor if parent, of course, continue. Now answer for this node, we'll have two sections. Answer node for the first thing. For 1, I should say, let's consider that 0 means minus 1 parity and 1 means 1 parity. Or let's say initially I'm allowed to choose now. So let's say initially I start with a 1, that means I'm allowed, and 0 means not allowed, 0 parity, and 1 means 1 parity. 0 means not allowed, 1 means allowed. So I will say that node of answer of 0 is from my subordinates, from my neighbors. Now I want the answer for both, like self node and then parent. I want for 0 as well, and I want the answers to be calculated for 1 as well. After being calculated, I will say that answer of node of 0 is the uh, like I want maximum across every neighbor I have. Like if at this stage, if I am not allowed to choose, then it will be comma. I think I can call for every neighbor of mine with a 1. And we will have a return type. I think LL will be good. And I don't think we'll require these calls anymore. But since called this, I have selected this current edge between node and neighbor, and it will be 1 plus. But the question is, am I allowed to choose? For every node, I know that if I'm allowed to choose, what is the answer? If I'm not allowed to choose, what is the answer? Let's try to print some stuff. Okay, okay, let's return the max for now. Of course, there are a lot of problems with my logic, but let's soldier through. Now I have to make a distinction between if I am allowed to choose or not. Let's forget about the array. Let's do it by pure recursion. If parity is 0, then I'm not allowed to choose. Then return for every neighbor I go. I will just, yeah, I will go to every neighbor and I will just I will just what is the maximum that you can provide me? Comma, same DFS being called with and with the parity of I think 1. So I'm allowed to choose. If parity is 0 and return answer. Like else, if parity is 1, and then I do the same thing, it will be 1 plus, then I send a 0. And also I return answer. I think return answer is in common in both cases. I think I require these brackets. Okay. If of course answer is an array, ignore the DP, so maybe DP or that. Just tell me. I have to provide myself as well. Past. Okay. Unexpected. Let's try to DP. Apply DP now. DP of DP of node, comma parity equal to answer if DP of node parity is not equal to -1, return this thing. Before name set EP -1. Does it work for vector? Probably not. No worries. We can just set it to -1. Let's try to run. Okay, it is passing. Probably this will fail in a lot of cases, but let's try to submit anyways. No, I did not remove the debug template. Yeah, as expected, a lot of wrong answers. I can show you. Yeah, so a lot of wrong answers. Let's try to understand where we went wrong. Okay, so first wrong answer is this is a very big test. 10, so not very big. Let's try to see. So this is the test case with 10 nodes, right? And the correct answer is 5, but I give 4. Here also the correct output is 4, but I gave 3. I think I made one small mistake. Like I have said that I will choose the first node only. Maybe max of this and the same thing with being called with over, I think I should say 0. What if I choose not to include the, so I will show you what my logic. So what I've done now, uh, before output, I just said that, okay, I can maybe choose the first set of nodes from the root, or maybe not. Like, what if I decide, said, what if I say that, okay, not allowed to choose the first one? Let's see if that helps us out even a little bit. Let's copy this test case, this 10, 5, 8 thingy. Let's try to, and I think I expect an answer of, I think, 5. I got 4. And what is the answer? User output is still 4. 10, 5, 8, 4, 6. Okay, so still not solved. Now let's think more where we may have gone wrong. Okay, let's make the tree. Yes, that will not be a harm. At least a 10 size tree I can make probably. Okay. So, let's see what we have. We have we have 10, so 5, 6, 5, 8, 4, 6, not 9, 1, okay, 9, 1, 10, 4, 10, 4, 1, 3, okay, 1, 3, 2, 3, let's 2, 3, 7, 9, 6, 2, okay, 6, 2, no? And 5, 10. Okay, then who is the root then? Can I just PR this T? Then maybe I will get an idea of what the tree may look like. Okay, 1 is connected to 9 and 3. Yeah, that will be easy for me to draw. 2 is connected to 3 and 6. 3 is connected to 1 and 2. Done. 4 is connected to 6 and 10. 5 is connected to 8 and 10. 6 is connected to 4 and 2. 7 is connected to 9 only. And 8 is connected to 5. Yeah. 9 is connected to 1 and 7. Yeah. 10 is connected to 4 and 5. Yeah. So we have this tree. So kind of like 1 and a 9 and a 7. And rest everything is 3, 2, 6, 4, 10. Very weird. 5, 8. So this is the tree we have. I think my iPad is visible. Yeah. So let's see. If we select this edge, 1, 2, 3, 4, no. Yeah, this, then come on. And I have to select this. So 1, 2, 3, 4, 5. Okay, I have to mention one more thing, that for one, if for one neighbor I am choosing parity 1, then for the rest I have to choose 0 only. That we did not do. Parity is, let's say I came with a parity. Okay, so if I came with a parity 1, na, I'm allowed. That means for 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 one of my chain, the okay, by default I'm choosing the first one only. What if I choose the other one? That has also been taken care of. But have I taken care of the fact that, should I say answer plus equal to? Yeah, because I'm doing it for everybody. Am I not? I just said to answer plus equal to. That's it. Okay, some more wrong answers. But for the second case, I gave 8. Wait, I think I made a small mistake. That, like, did I reset my answer? One plus. No, no, no. I cannot do this. The moment I do this, if I, the moment I choose one and tell it to find the rest, that means for my current level, I cannot choose one for anybody else. So let's do one thing. Let's make a choice. If parity is one, which neighbor will I choose? Right. Let's say choose the first. Let's say iterate to the neighbor. I believe there is probably a better way to handle this. So let's say I arrive at a neighbor and I choose that. So the answer will be for that you send 0 to the rest, and If you are a neighbor that is not been chosen, then the answer is one being sent out from them. So let's make a it's a C neighbor, chosen neighbor. Now let's say for neighbor to T of node, if neighbor equal to C neighbor, then answer plus equal to this of self of course, and neighbor and node, and parity will be 0. Else parity will be 1. Else if parity is 0, the same thing, but now let's try to run now. Your neighbor was not defined with this 218. Answer was not declared. Okay, I will take a small break of 1 or 2 minutes. Okay, okay, I have returned back. Okay, let's see where we could have done a mistake. Uh, let's see. Uh, okay, we have segmentation fault, so we have to solve that, I guess. Let's ignore this. We have a segmentation fault now. Okay, I have to do if name CNBR equal to parent, continue. If neighbor continue. Yeah, otherwise it will be an issue. Okay, now we do not want. We don't want to keep adding up. We just want to find the maximum of all the chosen quantities. Like I could have chosen that and could have gotten a better result. So I believe now it can be submitted. Okay. For the 13th case, we have time limit exceeded. but I think we are very close to our solution. Mm, don't really understand this error. What have I changed? Okay, it is probably failing because of this double loop. Because it is purely a star based tree. Just think how we can probably get around this. I do have one idea, but it will still be a double loop. Like if I am either I will select what the edge from the root to that, or I will not select. It's not like the calculation is problem. The calculation is not a problem because it is all memoized. Hmm. I guess let's keep it up to here for today. Uh, I will think about this and get back to it on the next class. Thank you very much for watching.